I promise this is not turning into a reaction channel. Hey, what's up guys, my name is Cherno, and today we're going to be talking about the PlayStation 5, specifically watching and reacting to the PlayStation 5 technical details deep dive video by Mike Cerny. So last week I put up my reaction to the new Unreal Engine 5 demo, and so many of you requested that I make a reaction to the PlayStation 5 video, and specifically this Mike Cerny deep dive video. Now, unlike the Unreal Engine 5 video, I have not seen a single second of this video whatsoever. I have no idea what it's about. I'm assuming it's about the PS5. So far, the only thing I know is that it's called The Road to PS5. It's 52 minutes and 44 seconds long, which is very long, so we'll see what happens here. We might end up splitting this into like multiple parts, or I might end up skipping through this depending how much is here. I don't know, we'll see what happens. I don't know how to react to this video or how to deal with it because I haven't seen it yet. And that will be a great joy to the number of you who suggested that I should retitle my video because it's not a reaction if I've seen it before. First of all, since when does the word react mean the first time you see something? If I throw the same tennis ball at you twice, are you just not gonna react the second time? Just gonna hit you in the face. Anyway, consider this more of a purist reaction. So let's dive in and take a look at this video. First of all, even before I hit play, this has a lot of dislikes. I wonder why. Probably just all of the Xbox fanboys or PC Master Race fanboys. It's interesting to me because like consoles in general seem to have so much hate attached to them, especially from people who just, you know, always maintain that PCs are superior, everyone should be gaming on PCs, and I just don't understand all of this hate. And obviously I don't know why these dislikes are here. I haven't watched the video yet, maybe it's complete trash, but from what I've heard, it's a very good video and the stuff that they're revealing is really, really cool. So I am actually really interested to dive in. I don't think that consoles should just be completely disregarded. I don't think that, like, this is a complex topic, and this isn't really like Cherno's thoughts on consoles, but I did just want to say that as a game developer and as someone in the industry, making a game for a console is a completely different experience to making a game for a PC. People don't really consider this too much from the actual creator's perspective. They just kind of look at it from the user and say that, oh, well, you know, my computer's more powerful than this console. I can do this, I can do that, I can customize it, I can, you know, why would anyone play on a console? It's just complete trash, keyboard and mouse is better, all of that stuff. And I get that, and that's fine. That's fine. In fact, the few games that I do mostly play on PC. But I do want to say that consider this from the creator's point of view. If you're making a game, making it work with a computer is a completely different experience and a completely different set of challenges to making it work with a console. You see, computers are all different. They have completely different sets of hardware. They might be super powerful, they might be super not powerful, they might be super weak, right? So when someone makes a game for a computer, they need to spend a lot of time basically degrading their game so that it can work on a wide variety of hardware. They have to come up with all of these different tiering settings. Like you need to have like a low tier, a mid tier, a high tier, an ultra tier. You know, a huge amount of graphic settings need to get exposed. But when you're a creator working on your piece of art, which is your game, you're not working at it in like some kind of degraded lower quality. You're working at it at the highest quality possible because it's your artwork, it's your baby. And then what happens is you need to make sure that you basically sacrifice the quality of your piece of art so that people with lower spec systems can actually play this game. And that can be painful. You know, that can be painful for a game developer. Whereas if you're developing a game for a console, you can basically guarantee that the exact same experience that you are designing will be had by the players who actually play your game. The people who enjoy your art are going to see your art in the way that you made it. That's special. You know, that is very special. Whereas with PC, who knows what kind of system they're running? Maybe they'll hate the game because you can't deliver the same kind of atmosphere because their system just can't handle it. So anyway, don't hate on consoles, don't hate on PC, let's just enjoy all the amazing art that people are creating. Okay, sorry about that. Let's get back into the video. Well, let's start the video.
Hi. Unfortunately, we had to cancel the talk that we had planned for GDC, but we do have
I don't know if I should skip this kind of
about
intro.
PS5, and
I guess not. I think what I might do with this video, because again it is extremely long, is I might just, we'll see how it goes. I don't know what to do yet. I don't know what to say yet at this point in the video, but I don't really want to skip any of it, so I might just edit out me watching it, and only kind of, I guess, include the interesting parts.
Better to bring that to
But either way, let me know what you guys think in the comments below, because like obviously like this is, you know, this is made for you guys to enjoy, and if I'm just ruining everything, then well,
and the one and only
sorry.
Mark Cerny. Without further ado, over to you, Mark.
Mike Cerny almost sounds like Cherno.
Thank you, Jim. There will be lots of chances later on this year to look at the PlayStation 5 games. Today, I want to talk a bit about our goals for the PlayStation 5 hardware and how they influenced the development of the console.
I just want to say, like, and again, nothing started yet, but I'm not looking at this as some kind of PC elitist who knows that this platform is going to be trash compared to a computer. First of all, just so that you guys are aware that even though, like, in general, consoles are situated at a lower price bracket, which does sacrifice quality. You know, you can't, like, a 2080 Ti is what, like $2,000 or something like that. Like, obviously that kind of level of hardware cannot be in a console, because otherwise it would cost a lot of money. I do realize that, but I'm still not looking at this being like, oh, it's going to be so much worse than PC. I'm actually really excited about this, and theoretically speaking, this has every chance to be better and to kind of facilitate better games in both graphical fidelity and in I guess, experience than a computer. It has the potential, and I have not heard anything about this platform yet. I mean, about like a couple of years ago, I think we did get some, back when I worked at EA, we did get some specs of the PlayStation 5, and I remember reading a little bit through them. They were like super confidential, and I'm sure a lot has changed since then. Obviously, I don't have a copy of that, and obviously I don't remember that, so we'll see. That's all I've heard. Since then, I have not heard anything about the PlayStation 5 or the new Xbox.
I think you all know I'm a big believer in console generations. Once every 5 or 6 or 7 years, a console arrives with substantially new capabilities. There's a lot of learning by the game developers, hopefully not too overwhelming, and soon there's games that could never have been created before. Now, it used to be that as a console designer, you'd somehow intuit what would be the best set of capabilities for the new console, and then build it in complete secrecy. For the PlayStation consoles, that period lasted through PlayStation 3, a powerful and groundbreaking console, but also one that caused quite a lot of heartache, as it was initially difficult to develop games for. So
Yeah, the PlayStation 3, like, for those of you who don't know, like, it had a slightly different architecture. It had like cell processors and stuff like that. It just, you know, it has something called an SPU. It was designed in a different way, where it was just not as easy to program for as just a standard kind of like PC-like architecture. And because of that, because it was kind of, I guess, a new hardware architecture, it took people, like some people like just did not know how to write good quality software for it, but it also just took the industry as a whole a little bit of time to get used to it. But what's interesting is the games that did actually leverage that architecture properly, they ended up really excelling, because the architecture, whilst unique and whilst special, did provide kind of difficulties in the games industry for certain people and certain studios. If used correctly, which was a difficult thing to do, then it really did deliver.
Starting with PlayStation 4, we've taken a different approach, roughly centered around 3 principles. The first of these is listening to the developers, which is to say that a lot of what we put into a console derives directly from the needs and aspirations of the game creators. We definitely do have some ideas of our own, but at the core of our philosophy for designing consoles is that game players are here for the fantastic games, which is to say that game creators matter. Anything we can do to make life easier for the game creators or help them realize their dreams, we will do. So
that's really important, obviously, because the people making the content are not going to be necessarily the people making the platform. It's like when you're making a game engine, you want to listen to the people who are using your game engine to see what exactly you should put into the game engine, what kind of workflows they expect, the difficulties that they're encountering.
So about once every 2 years, I take a tour of the industry. I go to the various developers and publishers, sit down, and discuss how they're doing with the current consoles and what they'd like to see in future consoles. This requires weeks on the road, as reaching the bulk of the game creators involves talking to well over 100 people at something like 24 publishers and developers. And it is incredibly valuable. By the way, the feature most requested by the developers, that was an SSD. which we were very happy to put in the hardware, but a lot of problem solving was required. I'll be doing a deep dive on the SSD and surrounding systems.
Yeah, no, I've heard a lot of things about the SSD, and in fact, without really knowing about the SSD capabilities of the PlayStation 5, in the Unreal Engine video, I did kind of like suggest that an SSD is probably playing a huge role in what was able to be achieved in that demo. I think the primary reason why developers asked for an SSD and why that's so important is because more and more of the game's assets are becoming extremely large. Developers are trying to develop higher quality assets, and higher quality assets, like simply put, they take up more data. They take up more bytes of data. Like they are bigger. And because they're bigger, you have to be very careful about what you actually keep on the GPU RAM, what you actually keep on the CPU RAM. You have to be a little bit more specific about what it is that we need to actually have in our GPU memory for immediate rendering, and what we can just not even keep in CPU RAM anymore. Like it was kind of possible with lower resolution textures to just have the whole texture in memory all the time. But now, because of these extremely high quality assets, and because that's being pushed further and further, and not to mention like open worlds, and the fact that we have just not even the quality of each asset is higher, but the amount of assets is higher. And we have all of this kind of data to deal with. Because of all of this, we need to be able to actually stream the data straight from disk into like RAM, and then eventually put it into like GPU RAM or something like that based on how it's required. But the point is that that's becoming a real bottleneck, because if the disk speed is just not fast enough for us to be able to immediately say, oh, I need that asset and I need it into my GPU RAM as soon as possible because I need to display it on the screen like now. That's a huge limitation, that's a huge bottleneck, and that was stopping a lot of developers from being able to just simply use larger sets of data because, well, the disk just can't keep up. PCs obviously, like recently, just the SSD speeds for PC with M.2 SSDs and all of that stuff, they're extremely fast, and that's not so much a problem. But with consoles, that was
later on in this talk.
That was a bit of an issue.
It's also key to make a generational leap while keeping the console sufficiently familiar to game developers. I think about this in terms of balancing evolution and revolution. Now, with PlayStation 1, 2, and 3, the target was a revolution each time with a brand new feature set. That was great in many ways, but time for the developers to get up and running got longer with each console. In the past, I've called this time to triangle. Here's what I had for those 3 consoles. To be clear, I'm not talking
time to triangle is quite a popular kind of metric
about time to make a
It can mean a lot of things.
game.
But in this case, he's basically just saying that, like, okay, let's just say this, you have a new platform, right? Here's a PlayStation 3, right? I want you to get a triangle on the screen, like from scratch. How long is that going to take you? And obviously, like, the lower that time to triangle is, the easier it is to do things with that platform. So for example, in OpenGL, if you're writing an OpenGL program, time to triangle is very fast. It's not like particularly difficult to do that, especially with like legacy OpenGL or DirectX 9, for example. Really fast time to triangle because everything is fixed function, everything is really simple. Modern versions of OpenGL, a little bit longer, and then if you look at something like Vulkan, your time to triangle is going to be a long time because you have to set up everything. It's going to be very long. So that's another example.
Developers
of that
will
metric.
be ambitious, and it may take them 6 years or so to realize their vision. What I'm talking about is that dead time before graphics and other aspects of game development are up and running, and trying to minimize that. On the other hand, if we're trying to reduce that dead time to 0, that means the hardware architecture can't change at all. We're handcuffed. We need to judge for each feature what value it adds and whether it's worth the increase in developer time needed to support it. So with PlayStation 4, we were able to strike a pretty good balance.
I really like this guy's talk, by the way. He's like very good at presenting, which is like refreshing to see in this industry. To say
and
the least.
familiarity. We got required learning back to PlayStation 1 levels. With PS5, the GPU was definitely the area we felt the most tension between adding new features and keeping a familiar programming model. Ultimately, I think we've ended up with something under a month of getting up to speed. That feels like we're striking about the right balance. I'll go into a bit more detail later today about our philosophy with the GPU and the specific feature set that resulted from it. It's also very important for us, as the hardware team, to find new dreams, by which I mean something other than CPU performance, GPU performance, and the amount of RAM. The increase in graphics performance over the past 2 decades has been astonishing, but there are other areas in which we can innovate and provide significant value to the game creators, and through them, the players. That's why the SSD was very much on our list of directions to explore, regardless of what came out of the conversations with game developers and publishers. The biggest feature in this category is the custom engine for audio. That's today's final topic. The push for vastly improved audio, and in particular, 3D audio, isn't something that came out of the developer meetings. It's much more the case that we had a dream of what might be possible 5 years from now, and then worked out a number of steps we could take to set us on that path. So here again are the 3 principles, the first being enabling the desires of developers to drive the hardware design. To me, the SSD really is the key to the...
By the way, I'm definitely going to watch this whole video. And I'm only 5 minutes in, and I'll probably end up splitting this up into multiple videos, like in terms of my reaction, because I'm sure there's a lot I'm going to want to say about this. But I'm definitely watching this whole thing. It's really interesting so far.
It's
And I do want to know everything about this video.
a game changer. And it was the #1 ask from developers for PlayStation 5. As in, we know it's probably impossible, but can you put an SSD in it? That was a discussion we were also having internally. It was clear that the presence of a hard drive in every PlayStation 4 was having a positive impact. A lot of things that would simply have been impossible at Blu-ray disc speeds were now possible. At the same time, though,
Yeah, I wasn't actually even considering disc speeds. I was thinking about more or less games that required an install, because that was a lot of games were kind of doing that. Blu-ray did, yeah, that's even worse.
in
So yes,
2015
that's...
and 2016, when we were having these conversations,
But that's also kind of to be expected, because a lot of this stuff is moving to a digital marketplace. Lots of games, while still kind of sold on Blu-ray discs, and you know, we're talking about like 50 gigabytes of data there, probably, if not more. You know, that kind of, I still feel like, as the industry as a whole obviously is more or less gravitating towards like streaming services for games, meaning that you can purchase like a subscription, and then you get like kind of like EA Play, I guess. You get like a set amount of games that you can kind of use in your library, and all of that is like a digital marketplace where you can also purchase games. And a lot of games are only distributed digitally, so it obviously makes sense that like discs are kind of going to be coming out of phase, and so are physical game stores and I guess game copies, right? And then it's more or less moving towards something like Steam for PC.
developers were already banging up against the limits of the hard drive, and a lot of developer time was being spent designing around slow load speeds. I want to focus in on just one number here, which is how long it takes to load a gigabyte of data from a hard drive. The difficulty being that hard drives are neither particularly fast nor flexible. If all your data is in one block, which is frankly not very likely, you can load 50 to 100 megabytes a second, depending on where the data is located on the hard drive. Let's assume it's on the outer edge, which means loading a gigabyte takes 10 seconds. If you compress your game packages, you can fit more data on the Blu-ray disc and also effectively boost your hard drive read speed by the compression ratio. We support zlib decompression on PlayStation 4 that gets you something like 50% more data on the disk and 50% higher effective read speed. Unfortunately,
Yeah, so this is part of the thing that people don't really consider as well. Compression, right? So obviously storing raw assets is probably almost never done, especially because disks, obviously, both hard drive installations and like Blu-ray discs have a finite amount of space, and it might not be enough. Everything is pretty much always compressed. Now, when you compress things, you're basically playing with like a little bit of a trade-off here. You can trade your CPU time or your decompression kind of time for less disk space. So in other words, instead of occupying like 100 megabytes of data, maybe this kind of texture asset or something occupies 50 megabytes of data. However, it's not ready for me to send to the GPU immediately as is. I can't just read the data off the disk and immediately give it to my GPU. I mean, obviously GPUs have like, the texture's probably not the greatest example, because obviously there are compression formats for textures that actually are decoded at like on the GPU at sample time and all of that stuff. So we'll just ignore that analogy. But the point is, you know, you have an asset, you can't just immediately send it to the GPU or process it on the CPU or do whatever you need with that asset before you decompress it. However, it's less data to read. So the point is, if you have a fast CPU and a slow disk, it's a lot better to kind of compress stuff and then kind of read it in and then have the CPU do the work on it, if you read less data than it is to read double the data and do nothing on the CPU to it because it's already in the right format. You don't need to transform it. So that's kind of what he's talking about here, that it. And he mentions zlib as a decompression library. Like zlib is a fairly heavy decompression like library. It's not, for example, like LZ4 is something that is a lot faster to decompress, but the file sizes are larger. Zlib actually compresses like quite well. It's fairly like the decompression time is going to be slower, but obviously in this case the disk he's reinforcing the fact that the disk is so slow that they're actually using rather heavy compression to kind of get around that.
Fortunately, though, it's highly likely that your data is scattered around in various files on the hard drive, as well as sourced from multiple locations within those files. So lots of seeks are needed at 2 to 50-ish milliseconds each. My rule of thumb is that the hard drive is spending 2/3 of its time seeking, and only 1/3 of its time actually loading data. Putting all of that together, a gigabyte is very roughly
That's why it's so important to keep your data together. It doesn't matter if it's in RAM or on disk, you know.
20 seconds to load from a hard drive. Now, a gigabyte is not much data. Games are using 5 or 6 gigabytes of RAM on PlayStation 4, so boot times and load times can get pretty grim. Or to put that differently, as a player, you wait for the game to boot, wait for the game to load, wait for the level to reload every time you die, and you wait for what is euphemistically called fast travel. And all of that leads to the dream. What if we could have not just an SSD, but a blindingly fast SSD? If we could load 5 gigabytes a second from it, what would change? Now, SSDs are completely different from hard drives. They don't have seeks as such. If you have a 5 gigabyte a second SSD, you can read data from 1,000 different locations in that second, pretty much at speed. As for time to load a gigabyte, this is next gen we're talking about, so memory is bigger. Instead, we should be asking how long to load 2 gigabytes. And the answer is about 1/4 of a second. I mean, that's amazing.
Wow.
We're talking 2 orders of magnitude, meaning very roughly 100 times faster. Which means at 5 gigabytes a second for the SSD, the potential is...
Now, this is a huge jump, obviously. You guys don't need me to tell you that. You can see that from the numbers. But I do want to point out that the hard drive on the PlayStation, not the best. So, yes, it's a huge jump, and this is really good that this is a thing now. Don't get me wrong. I'm not at all saying that it's not that good. It's brilliant. But it's even more brilliant because of how bad it used to be.
was that the game boots in a second. There are no load screens. The game just fades down while loading a half dozen gigabytes and fades back up again. Same for a reload. You're immediately back in the action after you die. And fast travel becomes so fast it's blink and you miss it. As game creators, we go from trying to distract
It's going to happen to all the tips that are displayed during loading screens. I'm not going to know how to play these
player from
games.
how long fast travel is taking, like those Spider-Man subway rides, to being so blindingly fast that we might even have to slow that transition down.
Yep.
Pretty cool, right? But for me, this is not the primary reason to change from a hard drive to an SSD. The primary reason for an ultra-fast SSD is that it gives the game designer freedom. Or to put
What he said, by the way, about slowing down, that reminds me of like when I first started making games and I was still in high school and all of that. My games were obviously so simple and so dumbed down, and like that they had like no loading screens. Everything was pretty much instantaneous. But I actually wanted to have a loading screen and a little progress bar because I was like, well, all games have that. I want to have that as well. And so I added like some thread sleeps in there just to make the loading screen like longer so that I could display something. And so, yeah.
Put that differently. With a hard
funny.
drive, the 20
This
seconds
is
that
like
it
a
takes
reality
to load
now.
a gigabyte can sabotage differently. With a hard drive, the 20 seconds that it takes to load a gigabyte can sabotage the game that the developer is trying to create.
Exactly, yeah.
I think almost all of us in the room have experienced this, maybe in different ways. Say we're making an adventure game and we have two rich environments where we each want enough textures and models to fill memory, which you can do as long as you have a long staircase or elevator ride or a windy corridor where you can ditch the old assets and then take 30 seconds or so to load the new assets.
Yeah, so that's really, really common. You're basically forcing the player into some kind of limited area of the map where there aren't too many assets actually needed to interact with or to render. And then meanwhile, asynchronously, you're streaming in assets from disk. And that might take a while, but that's fine because some other thread's doing that in the background. As long as the player manages to get to where the new assets are required in a longer time than it takes to actually stream in the assets onto the GPU and the CPU for like interaction and rendering and all of that stuff, then you're fine. But obviously designing your game around that can be problematic. It works for a lot of games, like there's, they just kind of, again, the developers design around that. They make these corridors, not necessarily because it adds to the story or the experience of their, artwork of their game, but because like it's necessary. So yeah, let's make a corridor here. It can be hurtful.
Having a 30-second elevator ride is a little extreme. More realistically, we'd probably chop the world into a number of smaller pieces and then do some calculations with sight lines and run speeds like we did for Haven City when we were making Jack 2. The game is 20 years old, but not much has changed since then. All those twisty passages are there for a reason. There's a whole subset of level design dedicated to this sort of work,
Yeah,
but still, it's a
sure.
giant distraction for a team that just wants to make their game.
It is, and the thing is, like, you're seeing the industry, like, moving towards this kind of, like, just works mentality, and that's really good. Obviously, it's really good when the person who says it just works actually means it, but the point is that having to deal with limitations can be not only disheartening and annoying, but it can really take the fun out of making a game. And when you're dealing with a creative industry, taking fun out of things, keeping people not in like a good kind of happy, positive attitude, that can hurt that resulting creativity. And that's a bad thing. If you can keep your developers, your artists, everyone happy, because instead of, again, worrying about how they're going to add another corner into this level because like they just really can't, they've already added like 5 of them, they're sick of this, they can't do this, like it's just not gonna, this is gonna be ridiculous, people are gonna play my game and be like, why are there so many corners? But they have to, because otherwise it's not going to work, or they can't, or they have to reduce the quality of their assets in their game. Like, that's very, very, very bad. All right, my camera just overheated, so hopefully that doesn't happen again, otherwise we really will have to split up this video. Anyway, my point is, if developers can just focus on making the actual game and, using their creativity, and the tools are not getting in the way of the job, that's just gonna result in better games. People miss this all the time. People think that, oh, why did they make this game like this? Why didn't they make, like, Battlefield used to ship with 20 maps, now it ships with 8, or Battlefront used to ship with, like, Battlefront 2, the original, had like 1 billion maps and so many playable characters, and now this Battlefield has like 8 maps or 4 maps or whatever it is. Battlefront, sorry. People say these things, but they don't realize how much harder it is to make content at this quality bar, not just because of the fact that they have to spend more time putting more details into their environments, into their characters everywhere, but because the hardware is also getting in the way. And being able to kind of put that aside and make this really easy and make everyone be able to express their ideas in a super, super good way, that is, I think, the single most important part of this industry. To make tools and platforms that do not get in the way of humans and their ideas and their creativity.
So when I talked about the dream of an SSD, part of the reason for that 5 gigabyte a second target was
Still
to
recording.
eliminate loads. But also part of the reason for that target was streaming. As in, what if the SSD is so fast that as the player is turning around, it's possible to load textures for everything behind the player in that split second? If you figure that it takes half a second to turn, that's 4.
By the way, if that were possible, that means that, again, you don't have to split your world up into chunks. You don't have to worry about, like, oh, I need this, I need that, because every single asset, like visual only asset. So like, obviously, if you still need AI running in the background, colliding with things and pathfinding and all of that, you still need the basic mesh for the world geometry and all of that loaded, and you'll need other assets, like always, for example, present in RAM, but luckily those assets are generally a lot smaller than really high detailed models and textures and all of that stuff. So if that were possible, you wouldn't need to worry about like corridors or even worry about splitting up the world into anything. The world could literally be pretty much infinite in complexity and detail because it's only showing what you're looking at. And unless there's a section where you can overlook the entire world and everything has to be in like max detail, which it probably wouldn't be because certain things would be so far away that you wouldn't really need to you'd have like some kind of proxy for them, like a lower LOD mesh or, some kind of, with Unreal Engine 5, I guess, some kind of, triangle culling thing that just figures out what you actually need. All of that stuff. If you can have that stuff, like unless you have that huge kind of overlooking thing, the actual like view of the player usually is rather small, and that's really cool. Obviously, if you're dealing with like a level editor where you're trying to design the world, and like the developers are using this tool to create this world, and they would want to see a lot of it at once, a lot more than the player usually. But
4 gigabytes of compressed
in general,
data
this is really good.
That sounds about right for next gen. Anyway, back to the hard drive. Another strategy for increasing effective read speed is to make big sequential chunks of data. For example, we might group all the data together for each city block. That removes most of the seeks, and the streaming gets faster. But there's a downside too, which is that frequently used data is included in many chunks and therefore is on the hard drive many, many times. Marvel's Spider-Man uses this strategy, and though it works very well for increasing the streaming speed, there's a massive duplication as a result. Some of the objects like mailboxes or news racks are on the hard drive 400 times.
Wow.
What I'm describing here are things that cramp a creative director's style. Either level design gets a little bit boring.
Yeah, so again, sometimes it's necessary to have a duplication of assets because they're part of a different chunk, and if you always have them in one location on the hard drive and you always have to, again, fetch from everywhere, that can actually be a lot slower than being able to say, okay, I need all of this streamed in at once. And obviously that's resulting in duplication here.
Or the data is duplicated so many times that it no longer fits on the Blu-ray disc. And you end up with hard limits on the player's run speed or driving speed. The player can't go faster than the load speed from the hard drive.
Yep.
And finally, I'm sure many of you have noticed that after a patch download, a PlayStation 4 will sometimes take a long time to install the patch. That's because when just part of a file has been changed, the new data can be downloaded pretty quickly. But before the game boots up, a brand new file has to be constructed that includes the changed portion. Otherwise, every change would add a seek or two. Even so, you can occasionally see this happening on game titles. They start to hitch once they get patched enough. With an SSD,
that's interesting. I haven't had too much experience with like developing for consoles and all that, so I've never really noticed this, but this is really interesting.
No seeks. So no need to make brand new files with the changes incorporated into them, which means no installs as you know them today. There's yet one more benefit, which is that system memory can be used much more efficiently. On PlayStation 4, game data on the hard drive feels very distant and difficult to use. By the time you realize you need a piece of data, it's much too late to go out and load it. So system memory has to contain all of the data that could be used in the next 30 seconds or so of gameplay.
Yep.
That means a lot of the 8...
Yeah, because the disk is too slow. RAM is obviously a lot faster, so you have to make sure that you don't literally pause your game because you're relying on disk load speeds.
Gigabytes of system memory is idle. It's just waiting there to be potentially used. On PlayStation 5, though, the SSD...
Because if the player suddenly makes a sharp left turn and then you just, oh, I need that asset, then it better be in RAM, because if it's not, then, prepare for like a second of just either no textures on that model because they're still being asynchronously loaded, or just like a pause.
SSD is very close to being like more RAM. Typically, it's fast enough that when you realize you need a piece of data, you can just load it from the SSD and use it. There's no need to have lots of data parked in system memory waiting to potentially be used. A different way of saying that is that most of RAM is working on the game's behalf. This is one of the reasons that 16 gigabytes of GDDR6 feels right for PlayStation 5. The presence of the SSD reduces the need for a massive intergenerational increase in size. So
yeah, they don't need to have 128 gigabytes of RAM or anything like that because the SSD is so fast that they just, I'm actually really interested to see the difference in speed between RAM and the SSD. I'm sure it's still quite large, and obviously like this is a different, like architecturally speaking, you know, you need RAM because RAM is what the CPU actually communicates with. The CPU does not immediately get data from disk and then start processing it. It has to go through the RAM to actually be, you know, for the CPU instructions to actually do anything. Not to mention that's where the CPU instructions are. They're in the RAM. But I'm still interested to see what the actual speed difference would be between RAM and SSD, which again, like, doesn't make too much sense because the SSD speed is only going to be as fast as the RAM speed because for the, as I just mentioned, you know, for the data to get to the CPU, it has to go through RAM anyway. But I'm still interested.
Back to the dream of the SSD. Here's the set of targets. Boot the game in a second. No load screens. Design freedom, meaning no twisty passages or long corridors. More game on the disk and more game on the SSD.
Yeah, and the deduplication of game data is relevant because of the zero seek time that an SSD has.
And finally, those patch installs go away. The reality, though, is that the SSD is just one piece of the puzzle. There's a lot of places where bottlenecks can occur in between the SSD and the game code that uses the data. You can see this on PlayStation 4. If I use an SSD with 10 times the speed of a standard hard drive, I probably see only double the loading speed, if that. For PlayStation 5, our goal was not just that the SSD itself be 100 times faster. It was that game loads and streaming would be 100 times faster. So
that's a hard goal to hit.
Every single potential bottleneck needed to be addressed, and there are a lot of them. Let's look at.
I'm very impressed, by the way, so far. Like, I mean, I don't know the technical details of how they've achieved this, and I don't know how real it is. Obviously, like, I assume it's accurate, but what he's saying so far, like, this is a big technical achievement. And I think with that, we'll probably pause there for today's video. I hope you guys enjoyed this little preliminary look at the PlayStation 5. We're about 14 minutes and 6 seconds in. I'm not gonna watch any of the video until the next time I sit down and do this. I'm actually gonna go away, do something else for a while, and let this data kind of process in my brain and see if I come up with anything else to say. But I hope you guys did enjoy this. If you did, please hit that like button. If you're new here, then don't forget to subscribe to the channel as well. Please let me know what you thought of this particular video and if you think that I should do anything else for the remainder of this video, because it is very long and obviously I have a lot of thoughts to say. If you're happy with me to keep kind of just putting up chunks like this, then obviously let me know and that'll be fine. Thank you guys for watching. I will see you next time. Goodbye.